All right, so we got your 3-1 homework here. Let's see what we're supposed to do on the first couple. Add and subtract the polynomials. Like that shouldn't be too hard. Please write in standard form. So the most confusing one up here is probably 3. Make sure you distribute that negative symbol. That's the big thing. Kids forget to use the distributive property. I don't know why. I never quite figured out why they do. But I also don't understand how juniors don't know that a negative times a negative is a positive. I don't get why that's such an issue. Now, the only thing I can combine are like terms. So I have this guy, 4p squared, and negative 9p squared. And I know that 4 minus 9 is negative 5. What else do I have? The next thing I see that's alike is going to be that. That's the only thing that looks like that, isn't it? So I don't see anything else looks like it. So plus 2p squared u. All right. There's this guy, and he ain't like anything else, so he's going to come next. Minus 5p q squared. And here's some like terms. There's a negative 7pq and a positive 11cpq. And I'm pretty sure negative 7 and positive 11 add to 4. So plus 4pq. And there you go. There's number 3. All right, moving forward. Multiplication. These are all fairly straightforward. My guess is for most kids, probably 7's pretty rough. What you do is you focus on any two of the binomials and work them out. And then you FOIL. X times x is x squared minus a 5x plus a 2x and then minus a 10. Now obviously you combine like terms. X squared minus 3x minus 10. And what's still attached to this? There's a 2 and there's a 5 minus x. And me personally, I would save this 2 for last. Like I'm going to just bring it on down here somewhere. I'm not going to touch it right now. Because if I double things now, I'm going to make this step, the next step, a little harder. You're just doing the distributive property. We're going to x all 3 pieces. We'll have x cubed minus 3x squared minus 10x. And after we've x'd all 3 pieces, we're going to 5 all 3 pieces. So plus 5x squared minus 15x, and then minus 50. Now we're going to combine like terms. I see one singular x cubed. Looking at my x squareds, if I put those two together, I think there's 2 of them. Now looking at my x's, I believe there's a negative 25x. And then I have this minus 50 floating around. And I'm finally at the end. But even then, I know some kids are like, man, this is forever. This isn't that long. It's really not. Kids will complain about something taking forever. And the same kid loves working on engines or something. They love doing things mechanical of nature. That takes time. Of all the things I do in life, math is actually the easiest thing. It really is. All right, so the next other one that would be, I could see number 4 bugging a lot of kids because we have xy and an x squared. Well, negative 4 times 5 is negative 20. X times x squared is x cubed. And then there's this y. And we're moving forward. A negative times a negative is a positive. Negative 4 times negative 9 is going to be positive 36. There's an x times an x, x squared. There's a y times a y squared. And now we're here. Negative times negative is a positive. So 4 times y squared, 4y squared. It ain't too bad, kids. Explain why the expression, I'm going to leave that number 8 for you. I'm going to leave number 9 for you. And then number 10. Solve by factoring. All right, I'll do number 10. You're doing 11. I notice that all 3 pieces contain an x. And if I pull that x, I'd be left with 2x squared minus x minus 6. And again, whatever you write needs to make sense. X times 2x squared is 2x cubed. X times negative x is negative x squared. X times negative 6 is minus 6x. Still equal to 0. Now we're going to try to create this trinomial right here. It takes a 2x and an x to create 2x squared. Factors of 6 are going to be 2 and 3. And I believe it looks like this, because the outside is going to make 4, the inside is going to make 3. And if the outside's negative and the inside's positive, we're in business. And again, for those of you who aren't just sure what's going on, I wish you'd go back in time around 5th grade and memorize your multiplication tables. But that was a choice you made back then. And here's where you pay the price. Remember, when you're older and you have children, they're in the 4th and 5th grade or whatever grade it is now, they learn their multiplication tables, make them learn their multiplication tables. Rote memorization is such a valuable skill. Now we get to use the zero product property. X must be 0. See that guy right there? Or 2x plus 3 must be 0. Or x minus 2 must be 0. All right, so two-step equation, 2x is negative 3, divide by 2, x is negative 3/2. Singular step equation, x is 2. Jump equality, change your sign, be done, good day. And I said you're going to do, sorry, you're not going to do 11, I'm going to do 11, you're going to do 12. See that 4? There's 4 answers to that thing. All right, number 11, multiply the polynomial a minus b times a minus b times a minus b to develop a general formula for cubing a binomial a minus b cubed, which is not a cubed minus b cubed. Never has been, never will be. And let's see here. All right, so we're going to do the same thing I did earlier. We're going to focus on 2 of them. A times a is a squared minus a times b, which is ab. On the inside, some kids will write negative ba, which is the same as negative ab. Order doesn't matter with multiplication, with the exception of matrices, and a couple of other things. A negative b times a negative b is a positive b squared. And when I combine like terms here, I have a squared minus 2ab plus b squared. Now, I still have this guy. I'm just going to put him out front because it's easier. And I need to use the distributive property. Thought I changed to purple there. There we go. A times a is a cubed minus 2a squared b plus ab squared. All right, now I'm going to distribute the b minus ba squared or a squared b plus negative times a negative 2ab squared minus b cubed. All right, so let's put this thing in standard form. The biggest exponents I see are these cubes. There's an a cubed minus a b cubed. Let's see here. What else do we have? We have, looks like this guy and this guy are like terms, right? So there's a negative 2 and a negative 1. That makes negative 3 minus 3a squared b. What else do I see here? I spy with my little eye that guy. That's a positive 3ab squared. And I think that's all of them. You'll probably never use that. Like, there are people out in this world who memorize this pattern. I mean, they exist. They do. I'm not one of them. Let's see here. 14 is the one I'm going to do next. A 14 by 20 piece of sheet metal has 4 square corners cut out. Each square has side length x. So we originally start with a sheet of paper that's 14 by 20. And we cut out some x's. We cut out these corners of x and x, x and x, x and x. And what we're left with is basically what looks kind of like a big fat cross or a big fat plus symbol. This is math. I probably shouldn't be talking about crosses. And let's think about what happened. This was 14 and we took away 2 x's. So this is now 14 minus 2x. And this was 20 We took away 2x's, so now it's 20 take away 2x. And, do this at home. Take your piece of paper, cut out 4 corners, and then do what it says. The sides will be folded up to form an open container box. The big issue I think kids have, of course, some kids don't understand what I'm doing here, but the other issue they have is how tall it is. Remember, these were x units tall. There you go. And there's your box, kids. So write expressions for the length, width, and height of the metal box. The height is going to be x. The length is going to be 20 minus 2x. And the width is 14 minus 2x. Write the expression in STD form, standard form. And so let's do that. This is volume. Volume is length times width times height, in case you forgot. Of course, order doesn't matter because it's multiplication. The volume is x times 20 minus 2x times 14 minus 2x. And this is, this is factored form. So we're going to have to do the double distributive property and then the triple distributive property to get this thing done. And it's not too hard. Let's focus on this stuff right here. We got a 20 times a 14, which should be 280. I'm pretty tired. Then we have a 20 times a negative 2x, which is minus 40x. I'm going to write that off over here. We have a negative 2x times a 14, which is minus 28x. And I'm going to put those together, and I'm going to get negative 68x. And then I have a negative 2x times a negative 2x, which is plus 4x squared. And then I'm going to actually just do the singular distributive property here. It just has to go all 3 pieces. And I'm going to rewrite in standard form. So the volume as an expression of x is 4x cubed minus 68x squared plus 280x. 3 says using your TI-84 or preferably looking at your factors from L, from 1, not L, from 1, and using your brain, determine a reasonable domain for your function. So I know that the volume, if I'm going to have a box, volume has to be bigger than 0, which means each side has to be greater than 0. So if I take my factors, x has to be bigger than 0, and 20 minus 2x has to be bigger than 0, and, because there's 3 side lengths, 14 minus 2x has to be greater than 0. And I have simple inequalities that I can solve. Shift over the 2x, 20 is bigger than 2x. X has to be less than 10. And so we have x is bigger than 0, x is less than 10. I'm going to shift the 2x right to make it positive, and I'm going to divide. And I get this. X is less than 7. This is the one that's most important, because if you exceed 7, this piece doesn't exist. So this one doesn't matter. These are what matter. I'm stuck between 0 and 7. So x is a number stuck between 0 and 7, or using inequalities, 0 comes 7. And it does say use your TI-84. So let's use the TI-84 to verify. It's also a great time to make sure that my standard form is right. So I did a zoom 6. Always do a zoom 6. And I'm going to play with the window a little bit. I'm going to look up, I don't know, 200. Actually, let's do 100. See if 100 is big enough. And I want to talk about this graph. Nope, nope, need to look up higher. Okay, I'm wasting time, aren't I? Let's try 250. I don't want to make it too big and then you not be able to see anything. Mother of Lord, sweet Jesus. Okay, 350. Some kids will like default to 1,000. I get why you do it. Now, speaking of domain, you'll notice that here we have 0, and if we can count, that's 7. And I'm going to look a little bit farther to the right so I can talk about some things. I'm also going to look a little bit down farther than -10. Parts of this graph don't make sense. X max 20. Now, when you start talking about the graph, this is where the real stuff is, right here. This is your real volume. What's happening here is x is bigger than 10. So if you plug a 10 in, 14 minus 20 is -6. This length becomes negative. This is all what we call extraneous stuff over here. That stuff over there, this is extraneous. It's right in algebra, but it's wrong in the real world. It's extraneous. So, and if you look at your x-intercepts here, because you can count, you'll see 0 and 7. And this is where the graph is real. All right, again, using your TI-84 to determine what value of x creates a box of maximum volume, which is why I was trying to get such a pretty window. That's going to be right here. All the cool stuff on a TI-84, on a graph anyways, is under second trace. And since I'm talking about maximizing, I'm obviously going to choose the word maximum. It's not rocket science, kids. And you'll notice it asks for a left boundary. So I'm going to get to the left of the maximum. I'm going to press the enter key and play along at home. I'm going to get to the right of the maximum. I'm going to press the enter key and I'm going to press enter. And there she is. It looks like it's 2.7039. X is about 2.7309, if I read that right. Yeah, I did. Good. And there's 14, which means you're going to let 15 is being left for you. And I guess I'll do some trig. An angle is drawn in such a manner that its initial side lies on the positive x-axis. This is what we call an angle in standard form when we get to trigonometry. And its terminal side passes through the point 4, -7. Find and evaluate the 6 trig ratios. The truth is, I should probably just be focusing on SOHCAHTOA with you because the ACT usually doesn't talk about the other 3. But we start on the positive x-axis and we rotate in such a manner that we terminate at 4, -7, or we pass through 4, -7. Now, trigonometry literally means, here's trig, triangle geometry. So we pretend that there's a triangle here. And while this is the actual angle theta, we call that guy theta prime, and that's what we use. Theta prime notation from geometry. I know you did it. You use prime notation, double prime notation, all sorts of things. And I know how you felt about it because I've taught that course in the past. To get here, we went right 4 and we fell 7. And we're going to find our hypotenuse. We're going to do a little a² plus b² is c². So 4 and negative 7 are your legs. 4 squared plus a negative 7 squared is c squared. Hypotenuses are always positive regardless of direction, because Pythagorean theorem is going to make it such. We'll have a 16 and a 49. 16 and 49 I feel like is 65. So that makes c the root of 65. And 65 is divisible by 5. It happens, what, 13 times? You know, think about this. Root 5 times root 13. You can't do anything with it. There's nothing you can do with it. So that's what c is. C is the root radical 65, however you want to say it. And, you know, most people here that live here in America are taught SOHCAHTOA. I don't know why I like saying America. Makes me feel like a redneck. Anywho, SOHCAHTOA. So if I'm here and I'm doing the sine ratio, I'm going to be opposite over hypotenuse. I didn't call the angle anything, did I? All right, so we'll just call it theta. Sine of theta is opposite negative 7 over root 65. And some guy 400 plus years ago said, let's make this harder. No radicals in the denominator. And a radical times itself is the number inside, always has been, always will be. Negative 7 times root 65 is negative 7 roots of 65. Cool beans. Now I'm looking at the cosine ratio. Here's cosine. She's adjacent over hypotenuse, 4 over root 65. And, you know, I still got to do what that guy said. I got to multiply top and bottom by root 65 to clear that radical. I get 4 root 65 over 65. Lastly, we have tangent, which is opposite over adjacent. So negative 7 over 4. Now we have the reciprocals. The reciprocal of sine is called cosecant. Sine says O, cosecant is a hoe. She is a hoe. Everybody likes that one. Favorite one. So it's hypotenuse over opposite. So root 65 over negative 7. Negatives belong in the numerator or out in front. The reciprocal cosine is a funny guy. He's called secant. He's funny because he's ha. And the hypotenuse again is root 65. The adjacent side is 4. And lastly, we have the reciprocal of tangent, which is called cotangent. And it is AO. It's the opposite of, or it's the reciprocal of OA. So it's going to be adjacent over opposite, and negativity belongs out front or in the numerator. It does not belong in the denominator, because that is how it is formally done. And there is your homework for tonight.